Right, so it seems a bit odd, this one, where you're actually just talking to your screen and there are some people out there. So I'm Drew Foster. I've been teaching a good while now, so I've taught from early years to postgrad. At the moment I'm teaching in Blackpool, which some of you might know is one of the government's opportunity areas because they've got to raise attainment and there's a lot of issues with vulnerable children. But today's session is going to be all about exploring creative thinking and problem solving. And one of the key things is I've been to a lot of sessions about this, but how you actually use it in the classroom, because there isn't many models out there for how to actually get that problem solving. So it's more than just 1 week, you know, when it's maths week every year. You have a quick look at that. You know, for a lot of the time, we often rewards students which are very fast, and I think it's really quite important to make sure that it isn't being fast, it is, well, being accurate, and more importantly, sticking with it. So rather than just listening to me, what I'd like you to do is have a look at this problem here. So which are the only 3 numbers it's possible to make? And just spend a minute or so having a go and see if you can work that out, and just think through how you actually, you know, actually went about it. So I'm not going to rush you too much on this one, but most important, can everyone hear me? It's like at the moment, I've got a few issues. My wife arranged a garden party today. So, you know, I've had to uproot myself from my normal office into my daughter's room. Oh, thank you very much. Now, what I have said is not to post any of the answers. So one of the things with like, when we're actually looking at problem solving, it isn't actually the answer which we're that bothered about. It's more the process of the student actually working through it. So rather than hung up on just getting answers, what we really want to do is get the students, so when they know it's right, they can actually prove it to themselves. And I'll talk a bit more about that later. So the next slide there. So, you know, I've changed this a little bit because I've done this training in schools where it's been far more NSET-M, you know, like mastery based, which, but when I was looking back at the slides yesterday, I just remembered, I couldn't remember any of them. So probably wasn't that useful. But by attending this workshop, you might understand why problem solving is an important focus of the maths curriculum, learn how to identify good problems, and finally acquire some practical advice for embedding problem solving in the classroom. And I think that is the area where most people, you know, could get more clarification, different ideas. Obviously, everything I say is probably not right, but at least it's a starting point so you can like see what other people are doing. So I don't know if many people know Dan Finkel, but he's based in Seattle. He has a website, Maths for Love, and he is very much about the playfulness of maths, making sure it's not just about the fluency, procedural fluency, but also about what makes maths so appealing to some people, which is really the fun elements of it. So what books are to reading is play to maths. Right, so this one you can join in and you can actually put your answers. So this is all the problems I'm going to today. If you like, if you know your problem solving, you're going to see them before because they're all the classics, because it's the classics are the best place to start. So we've got a sequence coming up. So how many regions do you think is going to be the next circle? Yeah, it's looking good, these answers. So what I'll do now is I'll just go through the sequence a little bit more. So this one, we've got 16 sectors now. So have a look at this one. We have now got 16 regions. So how many regions do you think is in that final circle? I could see some people know this one. Right, so let's have a look and see what it actually is. So the final one in that sequence is actually 31. Now, and this is sort of counterintuitive, but the reality of it is most of you have been sensible enough to think the formula was just 2 to the power of n minus 1. But if you had more examples of this and a lot of time and were tenacious, you would actually find out the formula was this. Now, I think this, PowerPoint is going to go out, so I'm not going to worry and linger too much about, explaining anything. There are notes with it which explains all the answers, so I won't be giving any answers in the actual workshop now. So the next part is problem solving and some of the greatest problems ever. So I don't know if many people have heard of Alcuin of York, but he was a great problem solver, writer really. He wrote books on it. He wasn't, I don't think he was necessarily, great at writing his own problems, but he would collect them and send them. And he wrote several hundred problems, which we still use today. So how will this help us? Well, if we've got problems which go back to the 8th century and people are still using them, then it might be a nice idea that we start with those ones because they obviously are classics and lasted. So if you have a look at your screen now, it's the puzzle of the 100 steps. Now, some of you will know this from Gauss, his famous story about Gauss. When he was very young, he was given this problem because his tutor, his teacher, was getting pretty sick of him because he was just getting through the work so quickly. And Gauss is so famous because he did it in just matters of seconds, came up with the answer, but he came up with a totally different way of answering the question to anyone else. So what I'll do is I'll give you, just a minute or so, 2 or 3 minutes, type longer if you want a bit longer, just to see what answer you'll come up with. Those people who know the puzzle, you can give tips by all means, but just don't give the answer quite yet. Please let me know if you've got an answer, because when we get, I'll just take it that I don't want to rush you too much, and I'll talk about the speed of problems later in this workshop. Right, so lots of people had that. Only one person wrote the actual answer in there. I'm not going to give you the answer because once you actually have figured out the answer, you can check it yourself. But the key thing to puzzles like this, and the problem with actually doing them in the classroom, is timing. So some students will get through it quite quickly. Some should be given the chance to do it over a longer period. And I'll talk to you about how I've organized my lessons so I can make sure that we have constant problem solving in the lessons. So what I tend to do is I make sure I've got a big bank of problems. I don't tend to choose them in advance because I sort of go with what I think the students will like that day, whether it's a short one or a longer one. And I'll just tell you about how I organise that in a little bit of detail later. So this is like national advice, the 5-part structure of problem solving. So why does problem solving matter? I'm not going to go into that because I imagine by signing up to this workshop, which I'm really pleased you did, that you are quite interested and probably think that problem solving is important. So what makes a good maths problem? That is important. About practicing problem solving and problem solving strategies, and finally placing problem solving at the core of your classroom, which is pretty tricky, I think. Like I've not seen too many examples of people, like which have got school-wide policies for how they do this. So this is one of Alkin of York's great puzzles. Again, what I'll do is I'll let you have a few minutes on this one again. Now, one of the key things about this puzzle, which I would, like get a bit of feedback on, is do you want to do the puzzle? Because this is a key thing. Sometimes I see some puzzles and I have just no interest in wanting to achieve it. Now I like this puzzle, so like I'm biased. It'd be interesting to see what other people think. And again, don't put the answer out. What I'll do is once everyone's had a bit of time, then people can like give tips and so on, but try not to just give the answer because it does spoil it. I'm seeing a bit of chat about the last one, about the Roman numerals. There are different versions of this puzzle. I never give students the Roman numeral one, if I'm perfectly honest. It's an advanced one. But like the answer is 5,050. But when I was looking at it, I was going, how do you do that in Roman numerals? It's really tricky because I think Roman numerals, like gets very tricky after you get past about, 10,000. So it was just there for my own interest. Oh, sorry, one other thing. I'm probably not really looking at the Q&As, just the chat. Good idea is just to tweet me later if you've got any specific questions. Right, so just looking at that puzzle, one of the key things which we're going to go on to next is what makes a good puzzle. Now, what makes a good puzzle is you guys have been here all day. This is like your, what is it, 4th or 5th workshop. Now, by this point, for me, unless the puzzle was good, I wouldn't be that keen on actually doing it. So it'd be interesting, like you can be perfectly harsh. It's like, did you think that was a good puzzle? Sometimes you might say, no, it's a good puzzle, but like, it's just not the right time of day for me. But this is something which we really need to work on when we're working with students. So here's another maths problem, and this is what we'll come across a lot. Well, first of all, you can type what you think the answer is. And secondly, do you think it's a good maths problem? I'm not talking about whether it's a good question, it's well written, but is it a good maths problem for teaching problem solving? And I'll go slow because I do realise that quite a few of you are watching the football or listening to the football at the same time. So like, I won't rush through it too quickly. So yeah, so I'll stop that there. So my feeling that this, and this is a personal feeling, I might be wrong, is not a great maths problem. And there's a couple of reasons why it's not a great maths problem. Is, you know, when we're looking at maths problems, I think the things which we really want to do is make sure that it's open and that it's also playful. So when you're teaching problem solving, it is sometimes a good idea to actually eliminate, you know, a complicated procedure fluency. So, you know, like within the test, they are going to get, you know, trig problems and, you know, iterations and all sorts of things in the problems. But at the moment, this is about developing problem solving skills. And the best way to do that is make it really open, so you could do it in several different ways. Make it playful, so straight away you look at it and think that's achievable. And I'll be talking about the low floor, high ceiling, you know, slightly later. So this is what, and one key thing when we're doing problem solving. So what I've got to the point now where I often used to do problem solving in the starter. And when I reflected on it, it was a bit of a disaster, because if I gave a good problem, which they were really engaged in, which it doesn't happen all the time. Sometimes they're in the mood, sometimes you get a bad question, you don't pace it to you don't know the students well enough, but then they would want to carry on with the problem rather than the lesson. So eventually I switched to something, again, this was a Dan Finkel thing, where I would actually put the problem solving at the end of the lesson. So I'd try and allot 10 minutes. You know, some lessons I needed to, you know, keep going with something, some concepts. But if I was lucky, I would have those 10 minutes. I would introduce the problem, and they would have a full 10 minutes to work on it, which seemed to work well. Now, I wouldn't give the answer, never give the answers in that lesson, but it did mean that the students were leaving thinking about mathematics. I did encourage, the biggest thing which I encouraged was resilience. So like students came to me the next day and asked me for the answer and talked to me about it, by all means. But on the whole, I didn't feel like I needed to give them the answer. Even if I just got another 5 or 10 minutes out of, you know, a quarter of the class thinking about maths outside the lesson, that was a big win. So does everyone recognize this problem? So this one is Joe Bowler, high floor, so low floor, high ceiling. Now, the whole point of this is it can be a very mixed ability class, but they can all actually get started with it. But as you get further through it, some of the numbers become more and more difficult to find. And this usually works really well with classes where you've got some students which have got gaps in their learning. So I'd like to know if anyone's seen it before I say anything else. Excellent. I see loads and loads of yeses, but I didn't want to ignore it because the fact is some people haven't seen it. What I will do is I'll signpost to Joe Bowler's website, YouTubed, later on, and there's just tons of these things. So it's not a matter of you know, having to spend a lot of time finding these problems. They do exist. There's several websites. There's the Open Middle, Robert Kaplinski. There is Simon Singh's work and so on, and I'll have links for all of those towards the end of this session. So this problem here is an odd one. Is it a good problem or not? Kind of chats on the thing. I'll give you 30 seconds to digest it, to check upon the latest football scores or whatever. I'm liking just how, you know, like the conviction which people have here. Now, when I first saw this problem, which, you know, some psychologists, you know, research and stuff, I thought it was rubbish. But then when I actually did it with classes, because well, give it a try and stuff, it is incredibly interesting. So, and I even found out that, you know, like this no great study or anything. It's like I was teaching, you know, from Key Stage 3 to Key Stage 5. One thing which I found was of the Key Stage 5 students, which were good mathematicians, struggled with it a little. They assumed that there must be an answer, whereas the year 7s, year 8s would be straight away and going like, well, that's just stupid, that. You can't. And that was the problem solving. It's like, you know, problem solving, knowing you can't do it is, you know, a breakthrough in itself. Because most students just think that every problem you give to them, there is a number. And they think that this is the whole search. There's no beauty of patterns or anything like that for them with mathematics. It's trying to get the right number to make the teacher smile and give them a tick. Now, this is a really nice puzzle, and it's a good way in, actually, and this was from Dan Finkel again. So this one, what you have to do is you actually have to find out what is the pattern. Now, I've done this, I haven't done it for the last year or so, I've done it several times, and it's really good fun, especially with certain classes. So, yeah, if you want, have a guess, what's the pattern? I'll give you some more. So imagine they are only allowed to give one answer as an entire class each time. So you play it towards the end of the lesson, you give yourself 5 minutes, let them chat about it. And like, if they get it wrong, then they're not allowed to have another try until the next lesson. So imagine a whole day's gone on and, you know, children do want to get it right. And this one does, you know, get some like, you know, quite a lot of engagement. So the next one is this. Anyone work out what the pattern is now? And again, he gets one more. So the next day, imagine they haven't got it right. Some of you will know this. It's like they haven't got it right, so you show them the next one. Now, what they are allowed to do as well is they can actually, you know, they'll say that some of their patterns can be, would this fit the rule as well? So you sort of take this in, if it's working well. Sometimes it's just a flop because they've done it before, the last teacher. But if that is going well, it is enjoyable. So we've got this one, and then this doesn't fit the pattern. And that is the key point of this problem solving activity, is you want to actually get them to say what doesn't fit the pattern. So, and the actual answer is, and you can, you know, really draw this out, is the numbers are, you know, increasing, they're ascending. That's it. It's, you know, because they're thinking about it'll be always +2, you know, they'll overcomplicate it sometimes. And it really is interesting how, like, for a lot of students, they'll be like, oh, you know, like, and it'll actually get them to think about it, be quite memorable. Now, here is one of the processes for teaching problem solving. To be honest, I think that the first step is just to make sure they have time to practice. So we've got lots and lots of content to cover. In fact, it's very tricky to cover all the contents, full stop. But I do find this way that, you know, depending on how long your lessons are, it's best if you've got long lessons. So if you've got an hour and a half lessons or an hour and a quarter lessons, it works really well. Hour lessons, it's planning for 50 minutes, thinking about the cognitive overloads, thinking about that time where, and then they know if they study hard and put that there will be, they find this relaxing a lot of the time, and as it takes a good few weeks, months, you know, even years, but they do start to enjoy it, and they'll come in and ask, oh, I've got a problem today. And like, oh yeah, as long as everyone is ready on time. And it just means rather than just filling the lesson like most students are very good at doing, it gives them some reason to actually make sure they're finished to a certain point so we could relax and do something which is a bit more playful. Now, I think like there's been lots of talk recently about, strands of mathematics and so on, and this is only my anecdotal, feeling, probably totally wrong, but is that as the students get older and older, so, year 7, year 8, not too bad, get them year 9, year 10, year 11, especially if you're getting new class, they much prefer procedural fluency. Tell me how to do it. What's the recipe for this? And this means that we're teaching lots of procedural fluency. We're showing them how to do the tests, which might come, questions which might be on the test. But because their conceptual understanding isn't developed quite enough, then as soon as a question's in a different way, they really struggle, and you'll get that, oh, I can't do this, put their hands up and stuff. So one of the things which I prefer in lessons is to try and teach them resilience. And also one of the things which I usually write on my handbooks, I do forget a lot, is it's not about the speed of solving it. It's actually much more important that they are resilient and get there in the end and don't give up. So it's trying to award effort rather than those students which are just, and with a lot of problems, you can put another thing in just to make sure that those students, actually, those fast students actually have something to do. Usually it's prove it, because they'll come over and say the answer is such a thing. You go we might be wrong there, how do you know? And that's, makes the lesson so much richer. So, and with this over-reliance on procedural mathematics, we get things like this happening. So a sledgehammer to crack a nut. And it's heartbreaking when you see this sort of thing, but you'll get this sort of thing where students are doing that. And it is completely, the whole idea about mathematics is, trying to make it so it's the least effort. Save your brain for later for something harder. But especially when you're getting 1,000 take away 7, it is a tricky, situation. And I would be surprised, well, unless actually there's some amazing schools out there, but I'd be surprised if most teachers haven't seen this occasionally. And, it is really missing the point. So what do we do about, problem solving? Well, first of all, it's quite handy to know what different types of problem solving are, because you're not going to just do one type, you're going to mix it up, because the whole thing about a problem is, and what makes it a problem rather than a normal mathematical question, is you don't know what strategy to solve it. And it should be completely unknown. So this, the people out there in the workshop which have seen some of these puzzles before, it will come to them quite quickly, because even if they can't remember the answer, they'll have strategies and so on. So I would say some of my favorite, examples of this is a low floor, high ceiling, the Joe Boyle sort of thing. Open middle, which I haven't talked much about, probably won't do in this session because it just isn't time. Inquiry based, collaborative and hands-on, which you're probably quite familiar with, but it's trying to get away from that special weeks for problem solving. So we have a maths week, or when year 7 start, we have a full week of problem solving. And then, because it isn't in our schemes of work and so on, it isn't very clear how we're meant to address this. It'll just have a sentence, problem solving. It makes it hard for the students to actually get that practice. So, suggestions. So I would say, and I imagine that you know, at least a couple of these are some of the best websites to start off with. Enrich, is fantastic. And I imagine that most people know Enrich. YouCubed is Joe Boyle, it's all free. Oh yeah, everything I'm going to show you today will be free. It's no good showing you stuff behind a paywall, because you obviously, you don't have the choice of what actually resources you have in school. Open Middle is the one which, if you like this sort of stuff, I would suggest that you actually go and have a look at afterwards. So if you go and do anything after this, workshop, it's just go and have a look at Open Middle. It's Robert Kaplinski. It's amazing stuff. And if you've read, I'm I'm going to forget the name now, you know, one of the How to Improve Your Teaching books, one of the recent ones, I'll remember in a bit, it does mention a lot about this Robert Kaplinski stuff. And the one which I probably like the best is Parallel by Simon Singh. So like, yeah, it's nice. I'm just seeing in the chat some people are backing me up about open middle, because yeah, I could just be talking nonsense, and I'm not, you shouldn't rely on everything I say, because a lot of the problem solving things is like, there's agreement problem solving is good, but you know, like there isn't much, you know, research about, you know, what effects it actually has. So like, it's one of those trickier things where, you know, like when you get the EF research and so on, because, you know, if a teacher loves problem solving, it will make a big difference. If a teacher isn't that interested, it could actually, you know, be to the detriment of the students. So a puzzle. So this one is from Parallel by Simon Singh. It's free. It's sort of a little bit out there, because Simon isn't a maths teacher. He's like incredibly intelligent stuff, and it is for more able students. But it's like a weekly sort of like competition as videos from, you know, like films, and the students, you know, the first couple of weeks, you know, like a bit, you know, sometimes find it a bit tricky, but then if you do it for like, you know, 3 terms, the students absolutely adore it. It does take some time, a bit of time to break them down. So yeah, can anyone work out what the answer is? So, oh yeah, that's it. So I couldn't see what is the missing layer. I'd like to know, because I've forgotten the answer. And on the chats, recommendations to people, because like, it is nice if people like say, yeah, I use this, it works really well. Or just to step in there, the people which have got an answer, explain why. Well, someone's mentioned brilliant as well. I haven't used that for a long time. So yeah, you do find you forget things. Yeah, it's good. And this, you know, like, I'm looking at the chats, and like, because it is very weird when you're doing it virtually, you can tell that people are actually involved in stuff. I know I'll be talking to lots of people which you know, watching the football and falling asleep and stuff, but there's lots of people which are doing the questions, and you've done quite a lot of sessions to, so like, it shows you that this is a good problem solving question, because you feel the need to try and solve it. And this is from Parallel from Simon Singh. So definitely check it out, especially if you've got like, you know, if you've got students, well, at the moment in lockdown, if you've got students which have all got, you know, access to computer things, it is a really nice homework. You know, like, and it gives you all the results back to you and stuff. And it's like, with the students I always start, sometimes they're only getting 20–30%. And I'm saying like, no, it's over time getting a better score. It doesn't matter what that score is. So here is my favorite puzzle of them all. So this one's by Sunil Singh, and he's the author of 2 wonderful books, Maths Recess and Pi of Life. And they're all about, you know, teaching mathematics, but not, you know, hung up on curriculum content. So, and I think Sunil believes this makes his lessons better and the students achieve more and take mathematics further. But this is the question. You won't have time to work it out now. And even if you have done it before, it's sometimes hard remembering the answer. So you've got the numbers 1, 3, 4, and 6. You've got the operations plus, minus, times, and divide, and you've got brackets. So you've got to, find all the numbers from 1 to 24, and you can construct the questions that only use basic operations, and each number 1, 3, 4, and 6 exactly once. Now, this is a low floor, high ceiling questions. I will give you a minute or two to have a look at it. It is a really nice one, especially if you've got a class which loves problem solving, because you'll find that it's very easy to get some of the numbers, but there's 1 or 2 numbers which are incredibly tricky. Sunil is so confident when he teaches this that he'll offer a pizza party for the whole class if they can get all 24 answers. And he's never had to actually do that pizza party yet, but the students are very engaged with it. Yeah, it's really quite similar to 24 maths. What's that, Bob's son, isn't it? Yeah, because he has like a tricky question, which he gives you, like if you chat to him on like Skype or whatever, but it's nowhere near as hard as this. I think it took me a couple of days to like sort of Bob son's 24 question, but this one, I'm not sure I did it without some hints. So that's just flagging you up to Sunil Singh, because sometimes I do a lot of reading on mathematics, but I find so many interesting things in his books, and obviously it's Chris Brownell. So these are American mathematicians, Canadian. The next session we've got James Tanton, who is amazing with exploding dots. Yeah, much better than me. So I would say that if you get the chance, go and see that. So moving further towards the end now, because I don't want to go over. So we've got Martin Gardner, recreational maths. So Martin Gardner was the absolute king of recreational maths. There's loads of books by him. Lots of people don't know about him because it's quite a while since he died. But if you do enjoy recreational maths, then don't all transcribe into lessons that well. Not like there's some of the other websites which are out there now. But they're really enjoyable, and you'll recognise some of the problems. So if you don't know of Martin already, this is one just to remember. But Open Middle is the one to really go and have a look at if you get time. So talking about Dan Finkel. Dan Finkel created a game called Prime Climb. I think it was one of those Kickstarter sort of initiatives. Now, I came across this from a recommendation, and the game is really, really good as a game in its own right, not to do with maths in any way. But, I think you'll probably have, depending on where you're teaching at the moment, you'll have some students where you've tried to teach them number bonds, you try to teach them the times tables, every which way. And if you get to the point where they've done TT Rockstars and they're still not getting it, this is the way forward. Because you just tell them, oh, this has nothing to do with maths or anything like that, it's just a game. So yeah, have a look at those little codes to begin with. Can you work out if there's any pattern there? They'll let you see, and then, try it for 11 and 12. Can you guess what 11, 12, and 13 will be? Can you spot that? Now, when the students play this game, they have no idea that they're learning any patterns. They just like the game because one of the things is you get extra rewards landing on primes and so on, and you can use the numbers in different ways. But the nicest thing is you can bump other players, which means you send them back to the start. And I'm not going to spend any time on it, just signpost it's out there. I've done some sessions on it before, but I usually make it so we have mini Prime Climb and actually play it ourselves. Yeah, so if you have got any answers, so that is, how the pattern progresses. I couldn't recommend this enough when you've got students which can't do number bonds. It's no good doing the same old thing again. This is a totally different way of doing it, and really successful as well. Now, one sort of problem I haven't touched on, so we're all talking about resilience, you know, we're looking at them actually finding strategies and not, you know, just finding, oh, I'm stuck. So, you know, like the answer is square, what is the question? Throwing some of those in, you know, sometimes these are really nice because if you've got 10 minutes, it will fit those 10 minutes beautifully always. See, like, and you know, like some of the, you sometimes find that the students get really quite ambitious with this. You know, like I can never, it's one where there's always students which will surprise you. So, and that, you know, it's just, that's the one I forget to do a lot is, you know, the one where you give them, you know, like the answer and they have to work backwards. Right, so, you know, coming back to, you know, to some problem solving, I think, is Alkin of York yet again. How do you make 10 from 1, 1, 5, and 8? So these ones, you know, like it's the middle bit is very open. What this is for higher, you know, achieving students in the fact that they're already quite good at problem solving. So you can do, it's the same old, you can use them, you know, the plus, the minus, the times, the divide, brackets, just once, the numbers once, but you can't do anything like exponents and factorials. So yeah, if you have not, you know, I'm basing this on a bit of honesty here, but if you have not actually seen this before, you know, like we can have a speed one here where you can send me your answer if you can work it out and your hand on heart that you didn't know the answer already. So I'll just give you a minute or so on that, and then I'll wrap it all up. Or someone asked for an example. So you're like, how you, there is only one answer to this, it's quite close, but like an example might be, you know, 1 plus 1, you know, subtract 5 times 8. And, you know, like if you were doing this with a class, obviously you get, because you don't find that any of the students get it straight away on this one, that you can get them to give a good few examples on this. Then like there is a big hint, which you do, which you drop, which I dropped just before the end of the lesson, where, and then I'll come back to it the next day or a couple of days later, and the big hint is you need a fraction in it. Well, it's nice people are still doing the square one. Here's some nice ideas for that open question one is so easy to do. So like, if you with your lessons, you actually, so the way I try and make this time is by really efficient starting the lesson. So what I want is I want to have the starter finish in about 7 minutes or something. It's like, because if it needs more than 7 or 8 minutes, it's not a starter, it's actually part of your lesson, isn't it? So I think I was listening to Mel from Just Maths and she was saying about the bread and butters, and she'd say, oh, it takes us a lot. And I'm like, well, it's not a starter then, that's actually part of your lesson. And I do agree with Mark MacLeod, even though I didn't originally, that starters, you know, like the kids do find them sometimes a waste of time. It all depends how you do them. But like, but if you're really fast with your starter, then you'll have plenty of time to teach your main lesson, and then you'll have that like 10 minutes where you can do some playful maths. You know, like sometimes it's countdown, it's like lots of different things which I use. And one of the brilliant things about this is like some students find out they're actually really good at maths, but it's got so many holes in like their, you know, like in their understanding, you know, previous topics and so on, that they can't achieve because like it's changing around. But whereas you're doing like recreational maths problem solving, it really is more about, you know, just that resilience of thinking things around. So the big one on that problem, I'll wind that one up, is that you want to create the number 0.8. If you can create 0.8, you can do it. I won't tell you anymore because it's quite good fun even from that point. So this one is quite nice, and you can do quite a lot of them. You know, like are these fair-made problems? I think it is. It's like, so how many pennies do you need to fill a classroom? So, you know, just go for it. Let's see what people think. How many pennies, I mean 1 pence pieces here, would you need to fill, you know, your classroom? I imagine they're all roughly the same size. The pennies aren't socially distanced because I don't think the, you know, biological entities. But having this mixture of easy questions to create and harder ones means that you can all, I find it makes my lessons much easier to do, because like sometimes you'll get the kids where like they are genuinely stuck and they need to just, you know, stop at that point and, you know, start again the next day. It gives you a lot more flexibility. So like sometimes you know, like after 4 or 5 lessons, I might do this 3 times. But like with lower attaining students, the thing which I really want them to do is when they come in and going like, oh, we're doing a problem today, and they'll come and ask, you know, yeah, well, if we work hard for the lesson, we'll do that. And you're thinking, because sometimes like maths can be the poor relation in some schools it's like, you know, the best lessons. But like if you can get it so where they're interested already asking questions, you're onto a winner. It's going to help the students, you know, through those years. So just to wrap up, oh, what's that? So like that's, oh, what's it? So million, billion, trillion, 2 trillion. There is a website, the Thermae Questions website, where it has all sorts of great question stuff. Like they're American, but like apart from that, they're great. So it'll be things like how many ping pong balls will fit into the Oval Office, and there's just loads of that. And then students aren't getting it right; they're just getting it to the right sort of values. You know, to how many powers of 10 out are they? So, but I would say that is for, you know, strong mathematicians who are interested. So just to sum up, I think this is to sum up, is I imagine some of you will have seen this 5 strands of mathematical reasoning at some point. It would have been touched on quite quickly and you're then forgotten, for me at least. So like on the right hand side, I would say like a lot of the schools I've been into are good at the right hand side. Like it's in the schemes of work, it's pretty obvious, and teachers to do like an amazing job of that. But the left hand side of those strands of reasoning, so you know, the ability to formulate and represent and solve mathematical problems, I just don't think, you know, like I might be wrong, I just think the students need more opportunity to practice, you know, and it should be like a playful practice as part of the lessons, a regular thing, you know, not just 1 week a year. And this adaptive reasoning capacity for logical thought, reflection, explanation, justification. And this is one of the few things, like I would say, that, you know, is part of, you know, like a real life. So if you've got adaptive reasoning and logical thought, you know, when you leave school, whether you do maths or not, you will always do better in life, because that's, you know, every business, that is what they really want out of people which can think of something which is creative. And you think about this, all of this is creative, because you can't just be told a procedure and solve these problems. Sometimes you might use a procedure, but a lot of the time you don't even need that.